Welcome back. So we've done some practice on, they gave us a picture of an alkene and we write its name. Now they flip it. This is, they give us the name, we draw the picture. So hept2-ene. Hept means there are 7 carbons in this thing. So I'm going to go 1, 2, 3, 4, 5, 6, 7. And the 2-ene means, well, first of all, before I even get to that, let's put single bonds between these because if they're going to be a molecule, there has to be at least one bond holding them together, or any unconnected piece of would just float away. So this is bare minimum. And now this says, starting from the second carbon, we have a double bond. That's what makes it a heptene and not a heptane. So first carbon, second carbon, and the bond can't be here because that would be hept1-ene. It has to be where the lowest number is the 2. So between carbons 2 and 3. That is hept2-ene. And if we were in a hurry, we could probably stop there, but they want a condensed structural diagram, so we should be adding the hydrogens. Remember that every carbon has 4 arms. So this carbon is using 1 arm to hold on to its neighbor. It has 3 left to hold hydrogen. This carbon is using 3 of its arms, 1 there, 2 there. It has room for 1 hydrogen. 3 arms in use, 1 hydrogen. 2 arms, 2 hydrogens. 2 arms, 2 hydrogens. 2 arms, 2 hydrogens. And on the end, 1 arm in use, room for 3 hydrogens. Good. That's hept2-ene. Now, next one, 6,7-dimethyl. I'm not really paying attention to this right now. Oct1-ene is the part I want to start with. Oct means 8 carbons, so 1, 2, 3, 4, 5, 6, 7, 8. And if we single bond all that, so far that's octane. Oct1-ene means starting from the first carbon, put a double bond. There we go. Okay, Oct1-ene is now done. And now this thing has some branches for us to attend to. 6,7-dimethyl Oct1-ene. So on carbon 6 and 7 each have a single carbon on them. 1, 2, 3, 4, 5, 6. This gets a methyl group. And number 7 also gets a methyl group. Okay, so that's the entire carbon skeleton. All that remains now is to put hydrogen on it. This carbon's got 2 bonds on it, so it has room for 2 hydrogens. CH2. 3 arms in use, 1 hydrogen. 2 in use there, so 2 hydrogen. 2 arms, 2 more, 2 bonds, 2 hydrogens. Here we have 3 bonds coming off this, so only room for 1 hydrogen. 1 bond coming off, 3 hydrogen. 3 bonds coming off this carbon, so 1 hydrogen. 1 bond, 3 hydrogen. And again, 1 bond, 3 hydrogen. Very often there's CH3s on the ends, assuming there's single bonds. So good. That's our condensed form. There's ways to condense this further where when you have a chain like this where CH2 happens 3 times in a row, you write CH2, 3. They're cool and they do save a lot of space. We don't generally practice them in this course. So if you've seen this, yeah, it's correct, but you won't be seeing it in our answer keys.